Hello everyone. Rate of change is an important concept in differentiation directly related to derivative. In this lesson, we will explore more application related to electrical electronic field. As you see here, that I listed a few formulas for everyone. Okay, so this formula is representing the instantaneous current because it's represented by the small letter I. You see that it's equal to derivative of Q with respect to time. So when we talk about rate of change, we measure the rate in terms of time. So if you see an equation like this, is related to differentiation. As you recall, the definition for amperes as the unit for the current is that the amount of charge related to certain period of time. So if you have an equation given to you in terms of charge, then you can find the instantaneous current at a time, at a specific time, by differentiating this equation in terms of time and then substitute the value of time into that differential equation to figure out the current. Okay, so the next formulas I would like to go over with everyone is the I, also instantaneous current, but we are talking about the circuit that has a capacitor in it. Okay, so in this case here, I have a capacitor. If you have the value of that capacitor, you multiply by the voltage, and the voltage is given to you as a function in terms of time, then you are differentiate that equation in terms of time with respect to time, multiply by the value of the capacitor will give you the instantaneous current. Alright, so this formulas relate to the voltage, and if you have an inductor in the circuit, and if you take derivative of the current with respect to time, multiply by the value of the inductor, then you will have the instantaneous voltage. And it's just something here that I list for everyone. Powers is equal to Ri squared. And the I here is we are talking about the instantaneous current. Okay, so we will explore how to work with all of these formulas later on in the lesson. Okay, so let me concentrate on example 1 for now. And then later on, I will remind everyone of all of these formulas. When do we need to use those formulas? All right, okay. So first of all, this question asked me to determine the instantaneous current through a resistor at 4.50 seconds. Okay, given Q equal to this. So this is the chart, and it's given in terms of a function with respect to time. So the reason I explain to everyone the difference with all of these formulas is that in all of this word problem, you just need to recognize which formula to use. So obviously, for this one, I can use I can figure out the instantaneous current by using this first formula right here. So I will use I equal to derivative of Q and then with respect to time. So this is the formula that I'm going to use. All right, okay. So instantaneous current through a resistor at 4.5 seconds. So a change at the resistor vary with time according to this function here. So that means, so when you have some amount of charge going through this resistor, a different kind of resistor will affect your charge, the flow of the charge through the circuit. And you can find the instantaneous current at specific time during that period. Okay, so obviously you're not going to use these formulas. Okay, you're not going to use this instantaneous current here because you are not given the capacitor. You also are not given the function V with respect to time. Alright, so this is actually quite simple. Then if I take derivative of, so given Q equal to 14t, so then this will be equal to 14, okay, subtract 2 times 18 will give me 36, and I take 1 away from the exponent t, so that just gives me t. And the last one is plus 15 times 3, which is 45, and I take 1 away from the exponent, so I have t squared. So now at this point, all we have to do is we are going to evaluate this at t equal to 4.5 seconds. Okay, I would like to pause a bit and remind everyone there's all of this variable here uh, in terms of time, and the coefficient, the numbers are given to you, is actually in 3 significant digits. Okay, in calculation you don't need to write the 3 significant digits here, but at the end, our final answer, we should present it as 3 significant digits because all of these numbers are given to us in 3 significant digits. So I will take 14 subtract 36 times 4.5 and plus 45 times 4.5, all of it square. So this will give me 14 subtract 162 plus 911.25. And okay, make sure that you know that you are finding the instantaneous current because of the definition for instantaneous current. So I is equal to 763.25 amperes. And if I want to round to 3 significant digits, I will have 763 amps. Alright, so I just want to remind everyone in 3 significant digits. Okay. So also a reminder to everyone is the ampere is the coulombs per time. Okay, then is very much similar to the derivative of Q's as a function of time. All right. Okay. So then this one is representing the current. Okay. So let me write this one as ampere. So I want to spell the whole word for everyone. Okay. All right. Okay, so let's move on to the next example. The next example I have here is the voltage applied to a capacitor. Okay, and this is microfarad. In this, here is the unit for this capacitor. Given V equal to this equation, and then determine the current at the time t equal to 45 seconds. Alright, okay. So what I'm going to do is I'm going to ask everyone to recognize what formulas we need to use. Okay, so I am going to again write down in this space what we need to recognize. Okay, so this one is the instantaneous current. And given Q as a function of time. Okay, now the next one is I equal to C times derivative of V with respect to X. Okay, so this one is also instantaneous current. Given V as a function of time and a capacitor is present. Okay, So we need to distinguish the difference between these two formulas. One is just dq with respect to t. So you take the derivative of q with respect to t, or the derivative of charge with respect to time. The next one you are going to use is you have a capacitor present in your circuit, and capacitor has a lot to do with the voltage, right? So capacitor is acted as the temporary voltage source. So if you are given an equation for the voltage in terms of time, then you need to differentiate that and then multiply by the value of the capacitor, then it will give you the instantaneous current. So the next one I also want to mention to everyone is the instantaneous voltage. Okay, so in this case you are given an inductor, and you are given a function for instantaneous current with respect to time. Okay, so this one is the instantaneous voltage given I as a function of time, and an inductor is present. Alright, okay, so keep this in mind. Alright, okay, and the last formulas is I also want to remind everyone of Ohm's law. So if you have a voltage source E, then what you do is you can multiply this with the resistor and the voltage. Okay, I mean the I. So Ri is the current. So voltage equal to I times R. Okay, so maybe I should switch the term over. Alright, so let me see. I think I may have yeah, I think I got it correct. Okay, E, so maybe I should put it as V. Okay, so capital V. Alright, okay, voltage will be equal to the current multiply the resistor. So if you want to find the voltage across the resistor, you need to take the value of that resistor, multiply the current through that resistor. And from here, you can draw this formula P equal to Ri squared. However, in this lesson, we are going to talk about P equal to Ri squared. So what we will do is we will be seeing this formula again in the next lesson. All right. Okay, so I just want to let you know that this formula is derived from Ohm's law. All right. Okay, so let's continue with the example that I would like to go over with everyone. And this one also talk about determine the current, even though it doesn't say instantaneous current, but it's in fact it's a small letter I, so it's instantaneous current. So the first thing you want to do in this question is you want to take derivative of the voltage with respect to time. So before I do that, I see quite a lot of radical expression here. So I want to change that into the exponent. So I will write V 8.64 times t to the exponent 2/3 plus 13.5 times t to the exponent 1/2 plus 25.5 times t squared. Then, having the exponent, I can go ahead and then I can differentiate. So I do it step by step. I multiply this with 2/3. At the same time, I take 1 away from the exponent, so that will be 1/3 plus 13.5 times 1/2, and then t to the negative 1/2. Okay, and I will have the 25.5 times 2 multiplied by t. So at this point, I will evaluate this at the times t equal to 45 seconds. Okay, so I substitute everything in at once, and then I use my calculator. Okay, so negative 1/3 plus 13.5 times a half multiplied by 45 raised to the exponent negative half plus 25.5 times 2 times 45. Okay, so just to make sure that we get everything down correct. Yes, we do. So then I am going to show you what I got on my calculators. Okay, so if you key this into your calculator, you should get this number. Add that with this number. Okay, and add that with this number. I know that you are using the Casio FX991MS, and I believe that this level you already know how to raise this to the exponent negative 1/3. Okay, so 45, you put the exponent bracket, negative 1 divided by 3, close the bracket, multiply by 2, multiply by 8.64 divided by 3, and should give you all of this number. So while doing this, or while listening to this video, I would like everyone to, at the same time, take a look at your calculator and try to key this in to make sure that you get the same answer as mine. All right. Okay. So when you add this three number, you should end up with 2297.625621. So as you see now, I don't work with like engineering notation or anything, but now I am going to use that for my next step, which is using these formulas. I equal to the value of my capacitor multiplied by what I just found here. So then I will put in 5.50. Okay, don't forget it's a micro, and I want to remind everyone that put your engineering notation on calculators. Okay, so make sure that you turn that engineering notation on, and now you multiply with what you have as found for the derivative of v with respect to time, evaluate at t equal to 45 seconds. You see that I use quite a few decimal because I want my number to be as accurate as possible. And I got 12.6369 milliamps. Okay, milliamp is what coming out from multiply the micro with this number. Okay, so micro multiplied with this number, and we are not finished yet. We need to put this in 3 significant digits. Okay, so then my final answer is the instantaneous current having the capacitor equal to 5.5 microfarad in this circuit, finding the derivative of V as a function of time will give me 12.6 milliamps. Alright, okay, so it's a quick review for significant digits. Okay, so if you want to round to 3 significant digits, this is your third significant digit, which is number 6. Then what you do is you take a look at the next significant digit to that, which is 3. So 3 is less than 5. So you drop the rest of this, and then you just leave the 6 alone. So it's 12.6 milliamps. Okay, so let's move on to the next example. Okay, I give myself quite a lot of space here. I give myself 2 pages for each of this example. I don't think I need that much, but hopefully I can put in here. I'm going to put a reminder for everyone. okay, reminder is a significant digit. So this is important. Okay, so significant digits, round to certain significant digit. Okay, so I believe that I have a video, and I post the link on Blackboard for everyone to review significant digits. Also, another thing I would like everyone to review is your calculator. In engineering notation. I know that you work with a calculator in engineering notation all the time, so we don't need to worry about this. And the calculator that we are using is the FX991MS, the Casio, and it should be easy to work with the engineering notation, because you can put in the symbol micro, and then multiplying, it should give you the symbol milli at the final answer. But the calculator won't give you the significant digits as 3 significant digits. We have to know how to do that. So another note I would like everyone to remember in here is to note the coefficient and values are given in 3 significant digits. Therefore, we need to round to 3 significant digits for the final answer. All right. Okay, so a few reminder for everyone. Even though it doesn't say anything about the significant digit for the final answer, but we have to understand that. So all of the numbers are given to us in the question is given as 3 significant digits all the time here. You see it's 45 second, but I put 45.0 second. And then we 5.5 microfarad. Instead of saying just 5.5, because each of these are 3 significant digits. And another reminder for everyone is to keep as many decimal places in calculation as possible. Because we want to make sure that we get an accurate answer at the end. Okay, because we have to round to 3 significant digits, so we don't want to cut off our decimal numbers, like the placeholder, because the more decimal places that you use, the better your answer should be. Okay, so I think I will continue with this example. However, I only have about 7 minutes left, and I don't want to rush myself. Okay, I don't want to rush myself. So I just want to recap the lesson, and then I will end the video, and then I will work with example 3 and example 4 in the next video. So just to remind everyone, this lesson about rate of change. So rate of change relate directly to derivatives, and we just work with the electrical electronic applications involving the instantaneous current, instantaneous voltage, charge, with respect to time. And between these two formulas here, we both have the instantaneous current, but which formula that we need to apply for certain problem. So this one, you don't have a C, you don't have a V, so obviously Q is given to you, so you are going to use this formula. And all the reminder has already been put into the last page. Okay, so this one is the difference between all the formulas. Alright, so for this example, I ask you to find the current. Sometimes they say current, or they say instantaneous current, but if V is given to you in terms of time, then it's definitely the instantaneous current, with the current going through this capacitor, given the voltage is in this form. And again, a capacitor is a component in electrical electronics that it acts as a temporary voltage source. So it has a lot to do with the voltage in this case. In differentiating this, I need to pull my exponent and then apply the differentiation, then put in the value for time, and use as many decimal places as possible in finding this product. And then adding all of this number, having your final answer, multiplied by the value for the capacitor and round to 3 significant digits. And reminder for everyone working with these word problems, we have to be mindful of significant digits, and we round to the required significant digits. But even though the question doesn't say anything about round to 3 significant digits, we still have to remember that the coefficient and the values are given in 3 significant digits. We base on that to decide how many significant digits for the final answer. Okay, so in order for you to have as accurate answer as possible for your final answer, then you keep as many decimal places in the calculation as possible. Okay, and put your calculator in engineering notation. Then if you want to key in the micro, the milli, and all the engineering notation, you should be fine doing that. Okay, so thank you everyone.